Jai Jindra, Namaste and welcome to my channel. Today we are going to solve the 62nd question of the problem solving series and the second question of backtracking. The difficulty level for this question is medium and this question has been asked in Amazon, Microsoft, Paytm and MMT. It's around medium to hard. Okay. Rat in a maze problem. It is a very it's, like this is asked in interviews. Okay, so you would have seen this question, and so let's look at the example and understand this question. We need to find the path for the rat to move from the start to the end positions, all the different paths. Okay, so let's look at this example. We are given a 2D array. So here you can see I've represented this array here. Okay, so 1 0 0 0 1 1 0 0 1 1 1 0 1 1 1 0 0 and 0 1 1 1. Okay, so from here to reach this path, a rat can move either left, up, down and right. Okay, 1 1 position. So if it moves left, it can only move left when there is a it can move to any of the position if the value of that position is 1. So if suppose this A00 matrix 00, it starts with 0, then it's not going to start only. It has to start with 1 and this has to end with 1. Then only it can move. If that is not the case, you return -1. Okay. So here it starts with 1 in this example. So if it moves to the right, it can't move. It can't go to the right because it's 0. So it can't go up here because it doesn't start with that, right? 0 0 index it is there, and it can't go left as well. So it has only one option to go down. Okay, so it goes down here. So we write D, and then it can go right also. It can go down also. Assume we take the path right. It went right. We wrote right. It went down again because it can go only down. So down, and then it again only can go down, so we wrote down, down, and then again right, so we will write right, and then again right, right. So this is one path which if it follows, it will be able to reach from source to destination, that is from 0 0 to n-1 n-1 if the size is given as n. Okay, and in matrices, the matrix is n comma n. Okay, we are given the matrix like this. Now this is one path. You need to return all kinds of unique path. So here, instead of traveling to the right, so it went to down, and then instead of traveling to the right, it went down again. So 2 times down, and then it went to right, right, and then it went to down, down, and then again right, so right, right. So these are 2 paths that are possible. Are there any other paths? No, they are not. Okay, in this example. So you need to return this as the answer. Okay, dr d drr comma d dr down, right, right. Okay, so I have actually solved this kind of a problem, count the number of unique paths, in question number 29 in arrays. But the difference was there was no obstacle here, but there is an obstacle here which is represented as 0. So it can only travel to 1. So this question can be actually interchanged, but the problem type of the problem is same. Okay, so now how do you solve this question, right? So you see, there could have also been an option to go to up. Here we don't have, but it could be possible. Okay, so 1 1 that won't be the smallest path, but it is possible. Anyways, what is the solution that is coming to your mind, right? So that question where we could have moved to any path, the optimized solution was using permutation, right? It can I may at the max travel m row and column, so m plus n, and the total number of traveling could be n. So m plus n cn. That was the way of putting the unique paths. But here we also need to return the path, and here there are obstacles, so it is little different. Okay, so how do you solve this? How can we solve this? So can we use backtracking? Like, since there are more number of paths, So once we go to one path, we get the answer, okay, and then we come back to the path. Like here, when we came here, we got an answer from this path, and then if we come back, and we can see that instead of going to the right, we could have also gone to down. So we come back and again we go to this and we see for one more path, okay. So we are backtracking here. So we can use the logic of backtracking. We can use the logic of recursion. How would you use the logic of recursion? What is the base case? So it starts with this. This has to be 1. That is one condition. And the ending part, when the index, the row and the column both reaches the n minus 1 row and n minus 1 column, then we get the base case. If we get the base case and the number that we have here is 1, that means we have reached our base case. So whatever the path we have traveled, we can store that path to the vector of string that we are going to give. Okay, I think I have told you the solutions already, and let me code it, then it will be very clear. Okay. So we have int n as matrix dot size. Okay, we have string answer. Now we will be returning vector of string will be returning, not vector of vector. So vector of string. Okay, let's write it as string move. Okay, and let's is equal to empty. Okay, which will be stored, and vector of string answer. Okay, now find recursive path. Okay, find recur path, and we give the matrix n and the index 0 0, and then we give the size of the matrix, and then we give the matrix, we give the string, and we give the answer where we will store this. Okay, and then finally we return the answer. Okay, now we define the recursive path. So void recur path, where we have int n. Okay, we can have it as yeah, it's okay. And what is this n is the size, right? So this is ij, right? So ij, we name it as mn. It's okay, or we can just return it as int I and int j. Okay, and then this is the size int n, and this is our matrix that is given vector int %mat, and then this is our n string move that will change, and then we have vector of string answer. Okay, now if that is the base case, okay, if I is equal to n minus 1 and j equal to n minus 1. So once we have got this base case, then what do? We just store this, right? Answer dot pushback, whatever the move that we have got, we store that, and then we return. Okay, we return this. Now what are the ways that we can do? We can travel left, we can travel right. One more thing what I have forgotten here is that if we travel one place already, there is no way we should travel it again, right? Because once we would have traveled this position, and then when it will backtrack, and then it can again go to this position, right? So from source, I followed a path and I got the destination. And then when I got the destination, I will backtrack to get other path. After backtracking and reaching the same position, if I try to go to the same position, I shouldn't follow the same position again, right? So we should have a visited array. Okay, so vector of vector int n comma like this visited array, right? Int visited n comma n. Okay, 2D array, and it should be defined here. We should give it here answer comma visited, and this answer. After that, int visited n comma n. Okay, fine. So once this is there, now we will write condition if I plus 1. Okay, so from 0 it will start. If it is less than n and j is less than n, so we are going towards right. The row we are moving. Okay, so this is right, and a matrix I plus 1j equal to 1. Okay, if I plus 1 and matrix I plus 1j is equal to 1, then what do? We add move plus equal to right. Move plus will be equal to right, and visited I plus 1j. Okay, move plus r equal to right, visited I plus 1j would be 1, and also we need to check, and visited I plus 1j is equal to 0. That means it was not visited in this path, because one path cannot be repeated. Also, because drd, and again I'll go to up, and again I'll repeat the path, so it should be the shortest path, right? That is one thing. So it should not be repeated again. So visited in this path, I plus 1j is equal to this visited array that is required, that's why is equal to 1, and then I will call this path again, recur path, where I will pass I plus 1j, and actually this move is actually okay, move plus r is equal to here, that is fine. I could have even used it, it's inside this as well, I plus 1j, then what do we give? N, then matrix, then move, right? Move, and then move, and then answer, and then visited. Okay, so once I have given this, I need to make this visited I plus 1j again as 0. That is required. That is that backtracking logic. So this is for down, this is for right. Okay, similarly we will follow for left, up and down. Okay, so what you will do for down, I j plus 1. Okay, we will check for I. If I is equal, if this one, if I plus 1 is less than n, for this one we will check if j plus 1, if the j plus 1 is less than n, we have not crossed the column size. Okay, for j plus 1 we will check in the down. For left we will check I minus 1. For up we will check j minus 1. Okay, so same thing we will do for left, up and down, and same logic we will use over here, and we will move this ahead, and then finally we will get the solution of the path. Okay, I hope this is clear. Try it yourself. The link to the question is given in the description. Try the code yourself, and then come to my code walkthrough section to see the solution that we submit in the lead code platform for this question, or Geeks for Geeks. Okay, here is the code walkthrough of the 60-second question, write-in a maze problem. You can see we have discussed the same example here. Okay, and yeah, the time complexity is exponential and the space complexity is L into X. To pass the matrix we need this space, and also Actually the recursive stack is also there, space is also that we have not discussed here. Anyways, let's look at the solution. So we call this we define this answer, and we have the size, and we define this visited array. And then if okay, this condition is important, if it is 1 then only we'll be traveling, okay, and then we will return the answer. If we don't get the answer would be empty string. Okay, so we call this, okay, we pass the empty string here, and then here you can see we check the base case. If it is reached n-1, if it is the if it has reached the bottom matrix, the row as well as the column n-1, mat n-1 n-1, then we pass the move that we get to the string answer, vector of string, and then we return. So this is for the down, we'll use this logic, and here we have just added it the d here itself, and then we backtrack and make it 0 again, and this will be recursively done. And this is for left, you can see j-1, we check I minus j1 if it is present or not, we need to check this as well, and we define this 1, and then again we make it 0, and we pass this for right and down as well, I minus 1 j plus 1, we check this visited array, we pass this find path like this. So this is the solution, and so we'll submit this and we'll see, submit this directly. So we see it has passed, all the test cases have passed. So see you all soon in the next video where I'll be explaining the 63rd question of the problem solving series. Jai Jinendra.